Find the most general form of the antiderivative for the following indefinite integral. So here what I'm going to do is start by separating this to the difference of two integrals. So I'm going to rewrite this as 6 multiplied by the integral of sine of theta divided by 4 d theta minus the integral of cosecant squared of 2 theta d theta. And so now we can see the two individual antiderivatives that we're going to need. So let's recall our antidifferentiation rules. Remember that if you have the integral of sine times a constant kx dx, that this integrates to minus cosine of kx divided by k plus c. And we also want to keep in mind that when we have the integral of cosecant squared of a constant k times x dx, that this integrates to minus cotangent of kx all divided by k plus c. So these are the two antidifferentiation rules that we're going to need here. So one last thing to note as we proceed is that the constant k of our sine function, we can think about this as sine of 1/4 multiplied by theta. So our constant is a fraction there. So when we antidifferentiate, we end up with 6 multiplied by a negative cosine of theta by 4, all divided by 1/4. And then this will be minus a minus cotangent of 2 theta, all divided by 2, plus c. And of course we want to simplify here. So with our first expression, we can rewrite this as 6 multiplied by negative 4 by 1 times cosine of theta divided by 4. And then we see we have a negative times a negative to produce a plus 1/2 cotangent of 2 theta plus c. And then last but not least, we can rewrite this as negative 24 cosine of theta divided by 4 plus 1/2 cotangent of 2 theta plus c. And this is our beautiful final answer. And so as you're practicing, we should always take a moment to double check our work. So checking antiderivatives is straightforward, and that all we need to do is differentiate the answer we just found. So let's go ahead and we'll let y here be equal to negative 24 cosine of theta divided by 4 plus 1/2 cotangent of 2 theta plus c. And now we'll differentiate with respect to theta. So we have dy d theta is equal to negative 24 multiplied by the derivative of cosine of theta by 4, which leaves us with minus 1/4 times sine of theta divided by 4. And then we have plus 1/2 multiplied by the derivative of cotangent of 2 theta, which is minus cosecant squared of 2 theta times 2. And then since c is an arbitrary constant, this is just plus 0. And we can simplify our answer here. We know, of course, that 4 goes into 24 6 times. We also have a negative times a negative. So this will produce a positive 6 times sine of theta divided by 4. And then we have in our second term that the 2's will cancel each other out. And just don't forget that negative. So this leaves us with a minus cosecant squared of 2 theta. And this is the function that we started with. So we can officially claim that this is our correct and final answer.